All right, good morning, everyone. My name's Tom Hanak, as she said. Today I'm going to be covering basic ultrasound system maintenance, procedures on how to back up GE and Philips ultrasound systems, and then we're going to be going over quality assurance testing for ultrasound transducers as well. A little bit about me. I currently work for a company called MW Imaging. I'm the senior service director there. I've been working there for over 16 years. Started off as a field service engineer, worked my way up to being the director. We currently have, I don't know, right now we have 6 engineers that work underneath me. And we just do service mostly in the Midwest. We supply parts throughout companies nationwide and probes as well. Prior to that, I worked at a local facility in the St. Louis area called SSM Health. I started there as a Biomed 1, worked my way up to 2 and 3 as well. Prior to that, I served in the U.S. Army, served 8 years under the MOS as 91 Alpha, which is a medical equipment maintenance technician, and also deployed under Operation Iraqi Freedom as well. Oh, sorry, I should use this. There we go, there's me. All right. A quick overview of what we're going to cover today. We're going to go over how ultrasound is produced, how the ultrasound system produces ultrasound. Just a quick basic block diagram. We're going to go over how to create system backup for both GE systems and Philips ultrasound systems. I'll show you some menu items in the utilities as well. Stuff like where you can find the IP address, MAC address, where you can do basic system testing on some of the systems. Where you can find the software versions, just basic menu items that you would need to record if you're going to complete a system backup. Then we'll cover probe testing, quality assurance. For probe testing, I got 8 tests that we're going to go over using the ultrasound phantom. All right, how is ultrasound produced? The core component to ultrasound and how it's produced is the transducer. Inside the transducer, you have piezoelectric crystals that convert electrical energy into ultrasound or mechanical energy, and vice versa, mechanical ultrasound energy back to electronic signals. In order to do this, the system sends out a transmit pulse. It sends electrical pulses to the transducer. These pulses are generated by a circuit called a pulsar circuit or a transmit card inside the ultrasound system. Once this electrical pulse hits the crystal, it vibrates it in response and generates an ultrasound wave that travels through the body. These mechanical sound waves hit tissue, organs, and they reflect what we call echo receptions back to the piezoelectric crystal. Once the piezoelectric crystal senses this ultrasound coming back to it, it vibrates again and turns these these mechanical signals back into electronic signals. These signals are then sent to the ultrasound system where it completes signal processing. These signals are sent to the beamformer, signal processors. These boards inside the system amplify the signal. They filter out the noise. They measure timing, and they determine the strength of the signal. Finally, you have image construction. It goes to the image processor or scan converter. It translates this timing and amplitude data to form your 2D grayscale image. And basically the brightness represents the echo strengths coming back to the transducer. Finally, the image is displayed in real time on the monitor, allowing users to observe anatomy, movements, heartbeats, or flow using Doppler imaging. Again, it's just a basic breakdown of how ultrasound is produced in ultrasound systems. Any questions? All right, importance of system backups. One thing that we want to make sure that we have every time we are completing a PM, my team and I, is we want to have a good backup. We want to make sure it's labeled with the serial number of the system, the software version on it, the time and date, and we make sure that we do this during each and every one of our PMs. So we do our PMs on a 6-month basis. So if for any reason the system is down, you're unable to bring it up, you got error codes, blue screen of death, you can have some confidence knowing that you have a good backup if it's labeled correctly. It's important for, obviously if you have a good backup, you can prevent data from being lost. Some important data that sonographers would have on there would be the user information, measurements, it would be workflow, annotations. All of these are saved when you create a backup for the ultrasound system. It assures that critical information is recoverable. You're able to restore system configuration and presets pretty quickly. We also use it in supporting troubleshooting. I don't know how many times I've gotten a call via tech support or had to go on a service call where one of the users, the sonographers, have been messing around with some of the settings on the system, and now they have image quality issues, or they can't figure out why it's doing a workflow a certain way. So if I have a good backup, I can always say, hey, well, this backup was what, from 6 months ago. I'm gonna throw this on there, see what it does, see if it fixes your issue, especially if I think it's a user setting or something like that the sonographer may have changed. Having a good backup minimizes downtime. If you were to have to rebuild all these measurements, annotations, individual user settings for the ultrasound system, if it was down, it would take you quite a bit of time to make sure that you rebuilt those by hand. 3 keys to a system backup. When I'm backing up a system, I want to make sure that I have these 3 things backed up every time. First thing I want to make sure that I have is license options or the system keys. These purchase features are unique to each and individual system. If you have your, whatever Epic systems, it has CV, which stands for cardiovascular. You can have OB systems. All of these are dictated by the license options. You want to make sure that the user settings are backed up. These settings include user-defined presets, measurements, workflows, annotations, DICOM settings, network configurations. And finally, I want to make sure that I have the system IP address backed up as well, so that I know what that is, so I can get it back on the network quickly. There's usually 2 types of ways that it's assigned to the system. It's either static, which is assigned automatically by the network administrator, or dynamic, which is automatically assigned by the individual PC or the network itself. So when we go over, when I'm going through the systems and the menu settings, I'm going to show you where to find, where to back up all these settings, where you can find your license options keys, and where you can find your IP addresses and MAC address for the particular systems. So we'll get started with backing up a GE ultrasound system. This system here is a portable system. It's a Logic E general ultrasound system. This one over here is a compact 5500P Philips ultrasound system. It's a P is a point of care system. So when we're backing up this system, the first thing we want to do is we want to make sure we power it on. For GE systems, we're going to go into the utility screen. We're going to go into system, and then we're going to select backup restore. It's pretty simple. Screen here. I don't know which one I'm on. Philips. GE system. Let's go back to B mode. All right, so this is a GE Logic E ultrasound system. That's me. All right, it's a basic 2D image of the screen here. On the system here, there's a button called Utility, which will bring you to this menu. Once we get to Utility, we want to be under the System tab here. All right, and then we're going to come over here to Backup Restore. For this particular one, gives you a little bit of information here. When the last time it was backed up. And the 2 things you want to make sure that you back up on this particular system is user-defined configuration and service configuration. If you come into the GE systems and you find out that you only have the user-defined configuration backed up, you're not going to have the options of the system. So if for some reason it's down, a lot of times if we're doing tech support on these particular systems and somebody doesn't have this key backed up, we will instruct them to grab their USB device, maybe plug it in their system and see if they can locate on the backup the license options key. If you haven't backed up the service portion of it, you're not going to find it. So two things you want to make sure you have: user-defined configuration and service. When we come down here, we're going to make sure we select type media. I'm using a USB device. Select it, USB drive 1. All right, and then I would simply click backup. Now sometimes, and I've done it several times, let me see, I'll just unplug it real quick, what happens? I'll switch screens. Sometimes when you're creating a backup, you go to backup restore. Sorry. And you come over here and you go to select the drop down. Well, it's already showing up here. But if it doesn't show up right away, your USB device, simply, because a lot of times you'll come into this page and this is usually where I plug it in at this screen, and it won't show up right away. It'll just show me DVD, CD. So in order to get that back, exit the menus, all right, go back to the 2D screen, bring it back up, and then you'll see your USB device show up. Just real world situation. Like I plugged it in, I don't see it, I don't know what's going on. And then just hit back up. I'll give you a little warning. Backup user defined configurations for the GE system. Yes, I want to do so. I should give you another one for service configuration as well. Yep. And if it's completed successfully, right, it'll give you a timestamp. It's not the right date because I don't think I have the right date and time when I shipped it. So yeah, so it should match the date and time of your system, but you can see mine's the 5th, so it's up here at the 5th. But it should give you a date and time finished, telling you that it's okay and everything's worked out properly for you. I think I covered everything there for backup GE systems. All right, since we covered how to back it up, so you know you got a good backup, you know you got your options backed up, you know you got user-defined settings backed up. We're going to go and cover where the option string is. So again, it's under the utility screen. Go over here to the admin section. Under here, system admin, it will give you a hardware ID number and your system serial number, and then it will give you the installed options key. What I usually make sure that I take a picture of the screen or write it down on a piece of paper, again with the serial number of the system, the date that I wrote it down, and the software version of the system. So I know exactly what the option string goes to. I'll take a picture of this screen, and then I'll also go to the connectivity as well. And over here in connectivity, this particular system is marked as DHCP. So if it's dynamic, you just make sure you got that checkbox, take a picture of the screen. If it's set to static, this box will not be checked. And then I have a spot where you can enter your IP subnet and default gateway. For this particular system and some of the GE systems, in order to see your static IP address, it needs to be plugged into the network. And then all of this stuff would populate. Wireless configuration as well. That's DHCP almost every time. So if it was on the wireless network, again, here you would see in this page your IP address, subnet, and gateway. Take a picture. Again, if you take a picture of the whole screen, you'll have both your hardwire settings and your wireless configuration settings. And lastly, we'll go in here. I don't have a wireless network set up, but if you had a wireless network set up here and it was connected, it would show you the network that you're connected to. Then you can go to your properties page here and record all of your settings for your security for that particular device. And it would show up right here. Your encryption type, your signal, the speed, and then the connection status and your SSID. All very important if you're trying to get this system back up. After it's failed, if you have a hard drive issue, if you have to replace a part, motherboard, processor went down, CPU has gone out. Finally, we'll cover where to find your software version, and it's under the system tab. not saving changes. Over here under About, the About tab here. And this particular is a R9.1.2 software version. So after you've completed your backup, you made sure that you had your license options key recorded. You made sure that you have your IP information recorded. The final thing that I would make sure that I do after the backup is completed before I eject the device. Now to eject the device, and I would make sure that, again, I have all that stuff recorded. All right, so last thing you want to do is go up to an ultrasound system and just see a blank USB in there, not labeled, don't know what it is. Yeah, you can put it in there, enter your computer and see when the file, if it is a backup file, if the date of the backup file, but it's not going to tell you software information. You'd have to be digging around for quite some time. Again, will cause more downtime for the system. So again, make sure you label it. Label it with the serial number, date that it was created, software version. One of the most important things to do. Go ahead.
In order to get to the admin,
You might be, yeah, you might have to be logged in. I think I am logged in as admin, but all of those are default passwords, right? So unless somebody's changed it, but
it's just nothing.
so it can be nothing. So a lot of times people they delete it out and they just save it as blank, right? But the actual password, if you had to log in under admin, is ULS ADM, and that's the default one that GE sets. And that's for I think that's both for Logic and Vivid systems. So ULS ADM. It is now. Everything before in the past was always CD DVD. So, but yes, I'm using USB devices that way, and also I can transfer. We have a larger database that when we create backups for customers that we do PMs for, we make sure that we keep a copy of it. A lot of people don't, but that's one of the things we make sure that we use USB devices nowadays, because that's what everything's gone to. So. For Kingston, yeah, that's one of the ones we go to. Kingston's ones we use a lot, and they're pretty cheap to find on the net. Now they're up to. We used to be able to get just a general like 2 gig device. Now they're not really making 2 gigs anymore. It's up to 4. So cheapest ones that we can find really, Kingston's. Any other questions? Yeah, go ahead. All right. We go here. Connectivity, configuration. Since I don't have a network up here, I don't think it's going to show me, but it would be under the security tab. Yeah, it would give you an option to install it if I had a wireless network programmed up. But yes, and that's the area that you would go to find it. Yeah. Any other questions? All right, we'll continue on. So we covered the 3 things that we wanted to back up: IP addresses, license options, and the user settings. Let's make sure we're at here. We covered labeling it. Good. Oh yeah. So let's go over here. Go back. All right. Turn over this. All right. Some important information to keep in mind when you're backing up older Logic systems in particular. Early on, some of the computers had a little options dongle, or sorry, call it a hardware ID dongle inside the systems. So if you're replacing the computer or the BEP and you failed to move that USB dongle over there that kept the hardware ID on it, if you had to recover the system, you wouldn't be able, your license option string wouldn't work. So you want to make sure that, and we'll cover it back over here, but when you go to this particular GE system, that should I want it more? that the hardware ID matches. We talked about it earlier. This hardware ID over here matches the option string. So if you're having issues with plugging your option string back in, and you go to look at the hardware ID, when you're going to recover the system, it will tell you what the hardware ID number is. So it'll say this is the hardware ID, load up your license option string. If it doesn't match, obviously it's not gonna work. So like on older systems, that was an indication like, oh, did I move over the USB dongle? So, and then.
Okay, so what if they don't match? What does that mean?
So if they don't match, then you go grab the USB from the other computer that you pulled out, and you just swap it over, right? So typically when people sell the PC or the computer, they pull theirs out, right? So a lot of people forgot to move it over, right? And if you've moved it over and it still doesn't match, well, then you're gonna have to get a GE field service engineer to come in and change it, or make sure that the hardware ID is correct. Back here. And for the load software to those systems, it manually allows you to insert it. So the load software to those particular Vivid systems, it asks you what the hardware ID is. Typically, it's the last 6 of the serial number of that particular system. You just enter it by hand. If you fat finger it or something, and you go to enter the option string, in order to get back to that spot to reload the hardware ID, you're gonna have to reload the system software again. So kind of a pain in the butt, but if you mess it up, that's why we always double check. That's why I'm having it up here on the screen. Double check that the hardware ID that you're entering in there matches the 6-digit serial number that you have on your system. Next one here. Uh-oh, stop working. I don't know which one to do. New hardware. Not right now. Not right now. There we go. All right, some additional information on GE systems that I like to include in here is that now on all of their newer systems, it's saying PMs are no longer required in the service manuals. So I know a lot of departments have then gone to the point where they're like, don't even put them on a PM schedule. So I still want to, I would say, I would advise against that, and I would still recommend at least completing an annual system maintenance on it. At the very least, you can go in there, back it up, and take a look at the transducers. So I still want to make sure that I'm completing the system backup routinely to have that information in the event of failures. All right, what's we got here? We covered static IP addresses and dynamic IP addresses. Again, dynamic IP is when the network protocol assigns the IP address. Static is when the IP address is assigned by your IT facility. Oh, sorry, wrong one. We're also going to cover where to find your IP address on the Philips systems. And with that said, we'll go over here. This is a compact 5500P ultrasound system. And I brought this one along here. The menus and settings are much like the Epics and the Affinity systems. So it's pretty easy to navigate through, but I wanted to use this particular system so you have some familiarity if you're going back and working with any Epics or Affinity systems or any of the newer Philips ultrasound systems. So in this particular system, we wanted to make sure that it's powered up. On the control panel console here, there's a button called support. Make sure it works. All right. So under support here, it's a little tough to see here, but we want to go up to this backup restore tab, and it's under the system management. So you're under system management, you go backup restore here. All right, it'll bring a drop down. Make sure you select your USB device, and simple enough, click back up. Now what's nice about these particular systems is it lists over here the items that it's backing up. And if we're looking for whether or not the options are backed up, like one of our Three key things. We want to make sure we have the user settings, the options, and the IP address. On the left-hand side of the screen here, it's called clinical options. Right here, you can see it's clinical options were queried and copied successfully. If you've got that file on there, then you can be safe to know that your options have been backed up on this particular system. If you scroll down here to the bottom, it also tells you that the system settings were successfully backed up to the media device. All right, so we made sure that we have a good system backup. We made sure we had the options backed up. We'll come over here to system management page, and this gives you your software version here of the system. So this particular one is 1.0.2, tells you the model, Philips 5500P, gives you the serial number information as well. A lot of people want to know what the current hardware version is. Current hardware version is A.0. So we covered having license options backed up, covered having user settings backed up, and then now we want to find out where the IP address is. So you go to network.com, go over to network settings. All right, so this particular one, this drop down gives you wired or wireless, right? This is where you can find your MAC address. And if you click on TCP IP properties here, it's going to tell you what your particular IP address is, all right? Obviously, this one's set to DHCP or obtain automatically. If it was set to static, this box would be checked and would just simply take a picture of this screen or record it on a piece of paper. Make sure that it's included with your backup. Again, we want to make sure that it's labeled. Gave you all the tools to label it, software, serial number, and date. A couple other cool features on this particular system. You can run a basic system test on this ultrasound device. It's going to ask me to unplug the transducers, but you can come over here. This is just a pass or fail test, but if you run it and the system passes, you can have a pretty high confidence that the hardware in this particular device is good. All of their diagnostic testing for their newer consoles is pretty good. It's pretty spot on. If there's an issue, it will tell you. It usually takes about 8 minutes to run, I think. So just click run, and it will go through, and it'll give you a pass-fail indicator. This one counts up and doesn't count down, but I think it takes about 8 minutes to run this particular test. We'll let it run, we'll come back to it. Let's see, we're good. Technical difficulties. All right. So we covered Philips systems, how to back it up. All right. Also for this particular, so we have to back up here. So once it's done going through its 8-minute diagnostics here, I'll also show you where you can go to the error logs and download those particular error logs on this system as well. Right here. All right, we'll come back to that. All right, phantom testing for ultrasound probes or quality assurance tests for ultrasound transducers. Is everybody familiar with a phantom? So basically, it's just a tissue mimicking device that you use for quality assurance testing on your ultrasound transducers. These are the tests that we're going to cover today. We'll do, the first one is going to be a what we call an air scan. So it's just a air scan of the probe. The second one we're going to go over is depth of penetration test. The third one's functional testing. The fourth will be geometric accuracy test. We'll go over a beam profile test, axial and lateral test as well, grayscale test, and color noise test. We use all of these for all of our PMs. So every time we're doing a PM on ultrasound system. We have a list of these tests. We include the probe model, the serial number. A lot of these are pass-fail for us, but some of them require actually including distance that you measure with your calipers. So we found that over time that if the customer is complaining of image quality on a particular transducer, sometimes you can go back through some of these tests and see, yeah, we can see some degradation in some of the functional resolution or the depth of penetration, particularly on those transducers. So we make sure that we record this information every time we do a PM, whether they have 10 probes, 2 probes, or whatever, we do make sure that we record them. And it's saved in our service management system software. So if we ever need to go back to it, we can go back and take a look. All right, here. All right, important issues for quality assurance tests. One, and the most important one, is patient safety. A damaged probe may produce excessive heat, electrical leakage, or inaccurate images that could harm the patient. Secondly, we want to make sure that each transducer is performing correctly for diagnostic accuracy. Poor probe performance can lead to misdiagnosis. Having a good quality assurance program can also make sure your images are consistent and reliable. Routine quality assurance testing ensures images are consistent over time and between different transducers, and can be effective in cost savings. Early detection of probe issues can prevent expensive system damage or repeat exams. Early detection of probe issues may allow for a repair rather than the replacement of the transducers. All right. So the first thing I say we do for our transducers is we do a air scan. And when we complete an air scan, we just basically select the probe. We put the probe on the ultrasound system, we select it, select the preset, and we check the air scan. This is the near field. This is the array of the transducer here. What we're looking for is uniformity across the entire transducer. This particular one, you can see dropouts or shadows. And so this air scan would fail. Over here on the right-hand side there, if you saw some dropout and you put it on your Phantom, this is what the dropout would look like on a particular Phantom. Go over here to 2D. I think I got this one over here. All right, this is the air scan of our 12L linear transducer. You can see for this one, I would drop down the depth, can increase the gain. All right, you want to make sure that you have uniformity across the image. You can see that there's no dropouts like there were in the other picture over there. The other thing I would do is I would flex here at the strain, right? Make sure I don't have any dropout or any issues. There's a spot in the cable that looked like it'd been run over or whatnot. You could either see it with markings or a little nick. I would go to that part of the cable, give it a couple flexes there, make sure I don't see any like 2D speckles or anything of that nature. Again, I would flex the strain at the probe connector, and then sometimes give the probe connector a little wiggle. All right, sometimes you plug in a transducer, you'll see a little blemish or dropout. It could just be the pins. So I'll come over here, give the connector a little wiggle, make sure they rub against each other. And then you may or may not see that disappear. So the first test would be an air scan. That usually will give you an indication right away whether or not the transducer is having an issue. All right. So I'll go back here real quick. Jump back real fast here. Okay, so we were talking about running the system diagnostics. This particular one passed. If it was a fail, it would just be in red and it would say fail. All right. Now another real quick. So if you needed to download the logs for any reason on this particular system, the other spot to do it would be over here, system management, log management, export logs, and then you would just click all three of these. Export to USB device, click OK, and then it will run through. So this is real quick. Jump back to the Philips system. All right, now it's gonna reboot. go back to quality assurance testing on the probes. You can, yeah. Yeah, there's no, typically that's what I would do. Yep, keep it on the same one. Now, I would only really be downloading the error logs if there was something wrong with it, right? So that's why I made sure to do it after that particular one. I don't know what's going on here. Did I lose it? Oh, that's why. This thing, I don't know what is going on with this guy. Oh, it went away. Maybe back. Nope. I don't know. I don't know what that is. Yeah, I don't know. I think I lost it. I know. He went in there and changed the settings on that particular one. Well, that one's gonna pretty much do ALS. All right, well, it's not my computer, so I don't want to mess with it. All right, well, we'll go back to, so that's why, hey, I had the handout, so we can follow along on the handouts. We went over functional resolution first, all right? The next test after that I have as the depth of penetration test. So this guy's still rebooting. Use this one right here. For the depth of penetration test, it's not up on the screen, but you can follow along in your handout there. The first thing I want to do is select the presets for the transducer. I want to adjust the depth and the focus to the max depth, and then I'm going to measure the depth with the electronic calipers with our wire dots in the particular system. So on your ultrasound phantom, I know it's tough to see, but afterwards you can come up and take a look. I'll go here, see if it'll give it to me. There we go. So let's see if we can bring these image. All right. Here. So these are called wire dots. Each one of these wire dots have a measurement between them. This is 1 centimeter between this particular transducer. This is a 12L, so it's high megahertz, low depth penetration. So for this particular one, I would measure the distance from the near field to the farthest dot that I could see. My focal zone's over here on the right-hand side. So let's see, I don't know if I can adjustments after that. So we'll go to calipers. Measurement here. I think that's the lowest one that I could see. All right. So I'd go to calipers. I'd measure the distance from the top of the transducer to the last wire dot that I could see. This would be my measurement, 0.96 centimeters, and then I would record that on our PM report. And this would be the depth of penetration that I would get for this particular transducer. I'll show you another transducer here on the Philips system. That one's still not working. All right. So when I'm performing a PM for these systems, I will typically create a patient name. I'll name it test. PM of some sort. Typically do the date. I don't even know what today's date is. 5/9/26. Close it out. All right. This particular transducer. Let's see. Not general. All right. A little easier to do. All right, same test, different transducer. You can see my wire dots over here on the right-hand side. Acquire that image, and I would freeze this image. Oh, sorry, wrong button. Wrong button. All right, freeze the image. Click measure. Start from the top. All right, and measures my distance. This particular one's 15 centimeters in depth, right? And I would acquire that image. All right, and that is the depth of penetration test. If for any reason this distance changed over time, right? So I come back to it and say maybe later I can only get 14 centimeters of depth. Then that would tell me that over time something's happening with this transducer, the image quality is degrading, and then I probably need to send it off for repair, get it taken a look at, or replace it. Go ahead.
So, I mean, you as the person doing this test could choose to alter your gain so that you're seeing something deeper than maybe is natural. I mean, what do you do? Do you just keep your gain straight down the middle the whole way? Is that the idea?
Yeah, so typically, yeah, for my temporary gain controls, I'll keep them right in the middle, right? One thing that will eliminate that is the presets on the system, right? So if you're clicking on the C51 transducer, right, click on the C51 transducer, that click the abdominal general preset, it will go back to that every time, right? So that's a default preset set by Philips, right? So I can always go back to that preset, or just one of the default ones. You don't want to go to abdominal general 456 or whatever, Lucy's whatever last name. You want to make sure you go to the Philips preset ones. Those don't change unless they've changed them. And if they make a change to those, it won't allow you to change the default presets, right? So you'll have to add, Lucy's name or whoever as that particular preset. So that's how you know if it's the default one or not. Okay, so we covered depth of penetration. Again, this particular one was 15 centimeters. If you see it going 14, 12, whatever, then you know the transducer is probably having an issue. We should get it looked at. And if you have any questions, go through another curved 5.1 on there, take a look and see what the depth of penetration is on that particular one. So the next test is functional resolution test. All right. In this one, we'll use a Phantom and image the anechoic structures on the Phantom. These sizes are usually 2, 4, and 8 millimeters. Targets, you can also measure the targets using electronic calipers, what we just did. You can adjust the focal zone to match the depth of the smallest target. And then we're going to examine the image, measure the depth of the smallest visible target, and record the distance. It should remain, again, the same over the lifetime of the transducer. This particular probe up here. So the anechoic structures are these ones over here. These are what we call the anechoic structures. And what I want to measure is the smallest ones that I can visibly see. For this particular one, I think it's the 4 millimeter targets. It's labeled on the Phantom, so if you ever have any questions, the Phantom is labeled. So ones that I would come to this page, I would freeze the image. All right, measure. Smaller ones are here to the left. All right, select it. For this particular one, I can kind of see that one down there. So that's kind of where I would go with it. And that would be the functional resolution. Depth of penetration will usually be larger distance than the actual usable resolution. So this one's about 14.6 centimeters. Again, I would record this information, curved 5.1 transducer, the serial number of the transducer, the distance that I measured for the functional resolution would be 14.6. If for any reason, like we said before, with the depth of penetration test, if you could only get 13 centimeters out of it the next time, there may be an indication that you're having an issue with image quality of your transducer. That's the functional resolution test. Next test we'll cover is geometric accuracy tests and measurement tests. For this one, we're going to shoot these wire dots, and we're going to measure the vertical and horizontal distance. We're looking for on distance, the tolerance on the vertical targets is within 1.5% or 1.5 millimeters, and the horizontal measurements is within 2% or 2 millimeters. Again, so we'll come back here, we'll hit these wire dots, And freeze the image. We're going to measure vertically, and then we're going to measure horizontally. And then I would acquire the image. All right, as many times I've been doing this test, I don't think I've ever seen it off, but hey, it's one of the things that they want for ACR accreditation, so we make sure we do it. Vertical, horizontal measurements. Test geometric actually test we completed. This test, the next test is called the beam profile test. I'll show you how to do it, but I don't use it. So I'm just come over here to the right hand side here. And one of the reasons I don't use it, I've never found it to be off or wrong, but so over here on the right hand side and go over here to measurements, beam profile test. This one's a little bit more difficult to do, especially on a mobile system, but you want to measure the wire dots between the left and right side. This one makes it very difficult. That's one of the reasons why I don't do it. So to create that measurement, it's looking for 5 different measurements. You can skip if you need to. All right, measurement here, measurement here. And what it's wanting you to see is as you come into the focal zone, which is right here on the right hand side, it's called what they call the focal zone, the focus point of the particular ultrasound transducer. As you go through these measurements here, what it's looking for is the beam path, right? So what you should see is when it comes into focus, all right, you can see where it's narrowing, and then when it comes out of focus, it's widening. Again, one of the reasons why I don't use it because it's very difficult to tell, but shoot, wrong one. I also feel like some of these tests were created for back when the systems were a lot older and you could see it a lot easier. It asks for 5 different measurements. Once I've completed that particular test, I would acquire the image, all right? And I found, again, why I don't use it a lot. I found no real benefit to figuring out why the beam is having an issue. So, I mean, I'm gonna see a problem with image quality if I'm having any issues with my beamformers. So you're gonna see it in the ultrasound transducer. So, but that's how you complete the beam profile test. The next test is actual and lateral resolution. And for that particular one, we're going to come down to this particular set of dots here. All right, and what I like to do is I find the 2 wire dots that have some space between them. If it's a mobile system like this where you got a large cursor, then I'll probably use the larger ones that have space between them. But again, I'll take a measurement here into the next wire dot here, acquire this image, and we would record this distance, 0.471 centimeters for the actual and lateral measure. I do it both on the vertical side and the horizontal side as well. So the measurements come down here. Same thing here. And here, take the measurement, acquire the image. Gives me my distance over here, 0.456 centimeters. And if I saw any change with this over time, where the measurements were off over time, then that, again, that would tell me maybe I have an issue with the transducer and image quality. A lot of times when you're gonna know pretty much when you come up to an air scan, whether or not your transducer is gonna be good for the most part. But this is all for, mostly for ACR accreditation purposes and, you know, to determine degradation over for the transducer over time. The next test is a grayscale contrast test. All right, come back here, freezing the image, go to the grayscale anechoic structures, freeze the image. And for this one, we're just, we wanna make sure we can see all shades of gray. It should be clearly visible, circular in shape, and vary in brightness ranging from low to high levels of contrast. So in this particular one, I can see all of them pretty clearly. Again, I would acquire the image. The final test is cable noise test. All right, so in this particular transducer, it's kind of like the air scan test in the beginning. We're going to go to our 2D image here, break it up. All right, come up here, and again, we said we would flex the cable, see if we see any issues. With this particular one, you can see I can see some issues with the dropout in that particular area. I would go to color, my color box. I would increase the box size. All right, and this is just for color noise. But I come over here, give it a little wiggle, see if I can see a problem. This particular one, oh yeah, I can see that there's an issue. Can you all see that? There's definitely an issue with this transducer. Yep. So I can also see dropout in the 2D image, and I can see that there's color issues with it as well. If there were no issues with it, I would just save the image and move on. If there is an issue with it, obviously I'm gonna let the customer know. All right, so that was for your 2D color. This particular transducer, neither one of these do continuous wave, but I would do the same thing in continuous wave. So I'd go to 2D, I'd go to continuous, we'll go to pulsed instead, all right? Go to pulse wave. I would come over here to my pulse wave signal, continuous wave signal. I would increase the gain to where I could see just a little bit of noise coming across in the spectral Doppler image there. Then I'd give it a little wiggle as well from the cable. And if there was particular noise in this system, you would see spiking, popping, something along that nature. You would see the signal go a little crazy, and you would even hear it spiking and popping on the ultrasound system. If there was no issue, I'd just simply save it, acquire the image showing that there was no issue. All right, back to my 2D image. All right, let's keep on this test. Any questions about quality assurance testing on ultrasound transducers? No. All right. Any questions in general? Anybody have any questions about the ultrasound systems, menus, anything? No, I think we got a couple minutes still. If you guys wanted to come up here and play with some of these systems, you guys can. I'll leave it out here for the next 5 minutes or so. Come out, take a look at the Phantom, play with the menus, look at the systems. That concludes the class I have for today. Yep, no problem.